All right, so this is the last lecture of pulley related problems, and we'll try to cover two examples um, related to inclined surfaces. All right, so the first question is from Summer 14, paper 4-3. This worksheet, the question is question number 16. And the question goes like this, and most of it is described in a diagram. A smooth inclined plane, so it's smooth. I mean, thankfully, friction is out of the equation. This entire length is 160 centimeters, and the vertical height is 40 centimeters. And above the other end, blah blah blah, particles P and Q, um, respectively, same masses, ঠিক আছে সবই ঠিক বলছে সব মানে it's pretty much everything that's here. Acha, let's see what's interesting. It starts to, so once you release, it starts to move up the plane and does not reach the pulley. So basically what happens, ওরা যেটা বলতেছে সেটা হচ্ছে দেখো, এই পার্টিকলটা নিচে পড়ে যাবে 30 centimeters. This particle is going to go up, but in this direction 30 centimeters. There is going to be a 130 centimeter gap between this particle and the pulley the moment the particle Q hits the ground, because 30 meter or 30 centimeter উপরে যাবে 30. But obviously, just like the vertical particles, vertical pulley, the situation is not going to be that simple. The moment particle Q hits the ground, P will have the same velocity as Q does, and just like gravity played a role in vertical pulleys, particle P কিছু দূর নিজে নিজে উপরে উঠবে and then থামবে, because ওই upward going velocity যেটা ছিল particle P এর উপরে, ওইটাকে তো বন্ধ করতে হবে। So ওই জিনিসটা হবে, and then P will go up a bit until mg sine theta, meaning gravitational component, weighted component down the plane, stops it. So এগুলো আমরা assess করতে হবে, মাথায় রাখতে হবে. And again, I'll show this with the diagram in a bit. So you need to keep in mind the forces at play. You need to keep in mind how pulleys work, ঠিক আছে? And those will be needed to complete these questions. So let's start with the first question. Find the acceleration of the particles and tension in the string right before Q reaches the ground, meaning when everything is taut. So let me draw the pulley. So this particle Q, this particle P, so ওরা বলতেছে এখানে 160 centimeters আছে, and this height is 30 centimeters, 30 centimeters, and the whole height is 40 centimeters. Acha. Now let's talk about the masses. Particle P is 0.76 kilograms. So mg sine theta, if this was theta, okay, আর এইভাবে mg cos theta কাজ করবে, বাট এখানে আমাদের রিঅ্যাকশন ফোর্স নিয়ে কাজ নাই। what other forces are needed? tension, এদিকে টেনশন কাজ করবে, টেনশন এইদিকে কাজ করবে, and weight, এটার weight নিচে কাজ করবে vertically down. So that is gonna be 0.49 into 10, so that is 4.9 newtons. So these are the forces. Okay, now when you let go, the particle Q moves down and particle P moves up. So let's form those simultaneous equations. For particle Q, since it's moving down, F equals to ma will mean bigger force minus smaller force into its mass into the acceleration. Now for particle P, it's moving up, so that is T minus mg sine theta. So 0.76 into 10 into sine theta. Now this is interesting. Sine theta বের করতে হইলে আমাদের কি করতে হবে? The good thing is, now normally theta value is given to you. But the good thing is here we have, oh by the way, একটা mistake. The entire length is 160. So this entire length is 160. So the good thing is ওরা আমাকে dimensions of the triangle দিয়ে দিয়েছে. So my triangle over here is 160 centimeter hypotenuse and 40 centimeters opposite. So sine theta, according to trigonometry of this triangle, should be opposite by hypo. Tick 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 tick. So sine theta is nothing but 1 by 4. So what I can do is instead of sine theta, I've just calculated that the value of sine theta in this problem is 1 by 4, right? So that's T minus mg sine theta is equals to its mass into the acceleration of the system. So these are the two equations, and when you solve them simultaneously, you should get the value of the tension and the acceleration. ठीक है, so pretty simple. Except the forces now are mg sine. I have mg sine theta in them. Now I'm not gonna waste time calculating. I'm just gonna pick the answer. So 16 হচ্ছে 2.4 meters per second squared, 3.79. ঠিক আছে? So 2.4. না না না, in this দেখো resultant force জিনিসটা হচ্ছে excess force, বড়টা মাইনাস ছোটটা। এইখানে দেখো আমাদের মাল্টিপল ফোর্সেস আছে। তুমি তুমি যেরকম জানতে চাচ্ছ, when you talk about resultant force you need to talk about the particles as well. Let's say এখানে you're talking about particle Q. What are the forces on particle Q? There are two forces, T and the weight. So resultant কোনটা হবে? Well, the resultant is going to be the difference between the bigger and the smaller. So এখানে tension resultant force হবে না, it's going to be the difference between them. What about particle P? There are two forces acting on them. When there are multiple forces acting on a particle, it has to be the difference between the bigger forces and the larger forces. That's what resultant means. যদি শুধুই টেনশন কাজ করতো তখন শুধুই টেনশনটা রেজাল্টেন্ট থাকতো। অলরাইট, now so we know the 2.4 is the acceleration, we'll be needing that. 2.4 is the acceleration. এটা আমাদের লাগবে, টেনশনটা আমাদের পরে questions এ মনে হয় না কাজে আসবে, because the next questions are all about kinematics. What happens after the motion starts and all of that. So the speed with which Q reaches the ground. Now if you think about it, আমরা জানি that is a very important value. সবসময় মনে রাখবা সারা যে ডাইনামিক্স এর কোয়েশ্চেনে বা পুলি রিলেটেড কোয়েশ্চেনে it is very important, it's almost always the case that you will have to calculate the value with which the other particle hits the ground, because oita is going to dictate what happens to the moving particle যেটা মাটির সাথে বাড়ি খেয়ে বসে থাকে না। সো আমরা সবসময় দেখছি যে পার্টিকেলটা নিচে মুভ করে মাটিতে বাড়ি খায় ওইটার স্পিডটা আমরা সবসময় ক্যালকুলেট করি লাস্ট মোমেন্টে, because that is going to tell me what was the speed of the other particle, in this case P, while it was moving up. So you've seen a bit why that information is necessary, and you've seen before why that information is necessary, and the good thing is they are guiding us here. ওরা বলতেছে এই Q এর স্পিডটা কি এটা বের করো, and আমরা ওইটা ইউজ করব হচ্ছে পার্ট 3 তে। Now how do we figure out what was the velocity of Q um, the moment it hits the ground? Well, we need to talk about the distance, because the distance it is falling is 30 centimeters. So let's keep that in mind. So it is falling. So for part two. So for part two, what information we have is the particle Q is accelerating at this rate, had an initial speed of 0. We need to find the final speed, and The height fallen, the displacement was 30 centimeters, which is 0.3 meters. Which formula goes with all these information? V square is equals to U square plus twice AS. Now, V square is what's missing, U square AS. And when you do the math, কত আসে? 4.8 into 0.3, that is 48 into 3 by 100. So that is V square equals to 4, 144 by 100. Answer আসতেছে 12 by 10, 1.2 meters per second. So this was the velocity of Q when it hits the ground. But at the same time, this was the speed of P at the same instant. So, mm, excuse me. তারপরে কি বলছে? Find the total distance traveled by P before it comes to instantaneous rest. Okay. Um, so এই ডিস্টেন্সটা মেজার করতে বলতেছে from the very beginning, যে once you let go of particle Q, when Q starts going down, ওই মোমেন্ট থেকে কতটুক P travel করতে হবে before it stops. So the motion is in two stages. কেন two stage? Stage number one, Q কিন্তু মাটিতে বাড়ি খেয়ে বসে আছে, ঠিক আছে? So this is particle, that is a terrible diagram, right? So stage one, let's call this stage one. At the end of stage one, at this stage, particle Q has just hit the ground, so the tension is gone. And by this point, particle P from its previous point has gone up by 30 centimeters. Let's keep that in mind. So distance 1 is equals to 30 centimeters. কিভাবে? Particle Q 30 centimeters পড়বে মানে particle P 30 centimeters উপরে উঠবে. So that's half the work done. Now the next half is stage 2. Let's call that stage 2. And in stage 2, what happens is there is no tension, but particle P still keeps on moving. Oh, by the way, this tension is gone at this point. It's gone. But particle P will move some more distance. So this was its position at particle P's position at stage 1. All right. And it will move from that position some more. ঠিক আছে? So let me use different colors so that it makes sense. So from stage 1, the particle will come here. This is the final stage. Eta distance 2 ta missing. So let's say distance 2 শেষে, it's somewhere here. This is the final distance, all right? And that is what we need to figure out. And এখানে কিন্তু particle Q বসে আছে. So the idea here is now we have to think about for stage 2, to figure out distance 2, we need to figure out what is happening to particle P at this point. When the tension goes away, in stage 1 the tension has just gone away, and now it has entered stage 2. But stage 2 তে এখন কি হবে? Stage 2 তে the only forces, the tension is gone, no tension, and it is mg sine theta that is the only force acting on particle P. And it was an upward going particle, and an upward going particle experiencing only one force acting downwards will decelerate, because in this case the resultant is its mg sine theta. So in this case, since only there's only one force acting on it, it is the resultant force, and turns out it is opposing its motion. And when the resultant force is opposing the motion, it slows it down, right? Now, what information we have, হচ্ছে, um, we know that it is going to come to rest finally, right? We know at entering stage two, the velocity, the starting velocity is what had happened at the end of stage one, that's 1.2. এখানে ফাইনাল স্পিডটা ছিল এখানের ইনিশিয়াল স্পিড, because finally রেস্টে আসবে, right? And what we want to know is কতটুক মুভ করছে. What's also missing is the deceleration. Now the good thing is we have enough information to figure out the deceleration, and that is F equals to ma. The resultant force is mg sine theta. So কেটে যাইতেছে, and so that's 10 into sine theta value কত, 1.5, 1/4 পাইছিলাম, so that's 0.25 পাইছিলাম, is equals to the acceleration value. So 2.5 meters per second square is the acceleration value. In this case, it's deceleration. মানে when the string goes slack because q hits the ground, only mg sine theta will be the force acting, and as a result, the particle p, which was moving, will experience a deceleration of 2.5 meters per second square. So minus 2.5 meters per second square. Minus canon because I know it's going to slow down. The theory tells me it's going to slow down. So let's go and figure out how much additional height it will get, additional distance it will gain. So that's v square is equals to u square plus twice as. So calculator ta bar karo. So s is equals to 1.2 square divided by 5. 1.44 1.44 by 5, 2.88, 0.288 meters. So this is the second distance. So তার মানে stage 1 শেষে 30 centimeters gain করছে, stage 2 শেষে নিজে নিজে thanks to gravity থামাইতে থামাইতে 0.288 meters gain করছে. So total distance gained, moved, is equals to 30 centimeters, so that is 0.3 meters, plus 0.288 meters, so that is 0.588 meters, or 58.8 centimeters. So notice how it's similar to the vertical pulleys. Vertical pulleys আমরা কি দেখছি, যে যখন the moment the string is broken, the moment one of the particles, the heavier particle hits the ground, right, we enter another stage of motion, and in that stage only gravity, only mg acts on the upward moving particle and tries to bring it to rest. And we also saw যে mg তো ছিল, and আমরা জানি যে when mg is the only force acting on an object, the acceleration or deceleration is 10 meters per second square, right? That's what we saw. But in this case, we don't have that value. We have to figure it out using f equals to ma. ঠিক আছে? And friction থাকলে জিনিসটা একটু কমপ্লিকেটেড হয়ে যায়, তো ফ্রিকশন থাকলে আমরা এখানে আরেক ফ্রিকশনও অ্যাড করে ফেলতে পারতাম, বিকজ তখন কি হইতো, mg sine theta along with friction would try to bring it to rest, because friction has a property যে regardless of what তুমি যেদিকে মুভ করতেছো ফ্রিকশন উল্টা দিকে কাজ করবেই, যেদিকে মুভ করতেছো ফ্রিকশন উল্টা দিকেই কাজ করবে. So in this case mg sine alpha theta তো naturally কাজ করতেছে নিচে, and together friction would have acted. So in order to find the resulting deceleration, আমার resultant force এর জন্য আমার mg sine theta এর সাথে ফ্রিকশনটাও অ্যাড করে নিতে হইতো, and that would have given me some a bigger value of deceleration টা আরো তাড়াতাড়ি হইতো. So that would have caused the particle to come to rest more quickly, because দুইটা ফোর্স এখন ওকে থামানোর চেষ্টা করতেছে. So this was an important problem because এখানে the takeaway হচ্ছে যে how um, you know mg sine theta played a role here, ঠিক আছে? How every calculation was related to mg sine theta. ঠিক আছে, বুঝতে পারছো? So particle q 30 centimeters নিচে নামলে particle p 30 centimeter vertically না, 30 centimeter or parallelly মুভ করবে, লাইক ডায়াগোনালি মুভ করবে 30 সেন্টিমিটার, ঠিক আছে? সো এগুলা মাথায় রাখতে হবে।